Hi, this is Robert from Part Fusion. This week I was inspired to look into a question that had been asked in one of my other videos about a year ago. I sell this product on the Tindy platform. It's a soldering kit. So I had an assembly video and somebody asked a question about how the LED works. They questioned whether the LED had a 555 timer that did the flashing, and another YouTube person had commented on that their LED is an RGB LED with a built-in chip, and that's the correct answer. You can kind of make out the chip just through the casing. It's not very clear. So what I was working on this week was actually trying to investigate and look inside the LED to see the chip. So I first started off getting the LEDs and using a pair of side cutters to snip the top off, but that didn't result in a very clean opening. So the technique I came up with in the end was to take the LED, saw with a hacksaw most of the plastic case before the inner parts, the electronic parts, and then I would use sandpaper, different grades of grits of sandpaper to smooth off the surface. So the end result is something like this. So these are not clear LEDs, but you can make out a small bit of the detail. Get the light in the right spot. So one of the things I was looking at is trying to look inside. So the first thing I did once I got this part in is take a magnifying glass, and you can actually make out just a bit more detail. But I wanted to try and get a good photo. So the magnifying glass gave a glimpse of the inside. I don't have access to a microscope yet. So I tried experimenting with some of the other optical pieces I have lying around. Like this is a piece off a projector. And if I line it up correctly, you get a bit more of a glimpse of the inside. Put this away. But I then started looking at, could I make my own microscope? And approximately this is the setup of a compound microscope. So you have an objective lens and an eyepiece lens, and your object is here near the focal length of this first lens. The image gets generated up to here. The next lens expands this image, so you can see this image too, so when you look down from the top. So I was trying a number of different reclaimed lenses. Here's a small one from another type of projector, and if you stack these up like so, you can get some better magnification. And my resulting microscope is something like this. So I have a piece of plastic PVC piping. This I used to mount on a drill stand, so I could move it slightly up. I've got a piece of paper here to kind of blacken out the inside. The objective lens is mounted in a bit of plastic, and then I've just built up the sides to get a good fitting just by using cardboard tube, like from cling film or tin foil. And then inside, just near the bottom, is another lens. So fitting that into place and bringing back my LED, if I can find it correctly. It gets expanded or magnified. I'll add in some pictures and videos of more close-ups of the LED and the use of the microscope. When we look at the detail of the flashing LED, it looks exactly the same. We have the anode, which would connect to the positive side of our power supply, and then we have the cathode, which would connect to the negative part of our power supply. And then in detail, when we look down, we have the anode leg coming up. It's then connected with a gold coloured bond wire onto a small piece of silicon, which is about 0.5 millimeter by 0.5 millimeter. It's then, the little IC is connected by bond wire to the anvil, the metal plate. That's the ground, or to the negative side, the cathode. And then we have a bond wire coming out to the blue, red and green LEDs. I could make out the bond wire going from the blue and the green, but it was very difficult to see if there was a bond wire or how the red was bonded to the cathode. If I can get access to a metallurgical type microscope, I may be able to decap and investigate the internal structure of this built-in integrated circuit. Thank you.